Okay, good evening, everyone. It is 6:11 p.m. Central Time. It is Monday, December 12th. This is session 7 of 9 for the Intro to Coding Live. And tonight we are going to be covering two topics. One is pretty straightforward, and the other one is going to be a little bit of a brain melter, but no need to worry. We're going to explain it. It's for exposure to the concept. It isn't anything that you'll need for the application process to go into Code Platoon, but it is good to know basically that it is out there and what it is and how to approach it. So the first concept that we're going to talk about tonight is truthy and falsy. And all that is that each value has an inherent Boolean value, generally known as either truthy or falsy. There's only a handful of falsy values, which are false, 0, an empty string, null, undefined, and not a number. Everything else is a truthy value. All right. And why that becomes important is we can use this in our conditional logic. All right. So like if we were to, sorry, got Mo paying me a visit already. So the wife is out of town on business. So everybody's been super needy today. So if we look at just a basic true and false statement, all right, so we could say if 5 is greater than 4, return, or I guess we can just console.log. This is true. Else console.log. This is false. All right. And if we run this, 5 is greater than 4. So I would expect that I would see this is true in my console. All right. This is true. Now, if I say if 5 is less than 4, right, I would expect the opposite. That is not a true statement. Right. And what these are doing is this is a logical operator. So it is basically being reduced down to the computer by either true or false, right? These are both Boolean values. Notice how they're blue. There's some special color protection there that gives you a heads up. And so every value that we have, right? So if I just put an empty string in here, I mean, look at this, falsy is, so that's an empty string. So if I just feed an empty string in here, I would expect that the computer is going to resolve this to false for me, right? So this is false. And the same thing, if I just put the number 0 in here, this is also false, right? However, if I put a string of 0 in there, this is true, right? And so these 6 values, false, the number 0, an empty string, null, undefined, and not a number, if you just use that value, that will resolve to a falsy value, right? So if you just put that value into a logical operator, it is going to turn into a false. Everything else, so, and the only tricky one is just a string 0. But like if we put false in a string, it is still a string. So it is not reading it as a Boolean value. It's just looking at it as a non-empty string. And any non-empty string will return a truthy value. Empty array is truthy, an empty object is truthy, excuse me, and an empty function is truthy. So pretty much everything under the sun in JavaScript, except for these 6 things, will resolve to true. Any questions on truthy or falsy? And I will say, like, a question I get a lot is from other classes was like, why are these, like, who picked these 6 things and why are they falsy? Whoever compiled the JavaScript language decided on it. I'm not sure why they decided on it. It is just the way it is. It's just these 6 values are falsy. everything else is truthy. All right, and if we don't have any questions on that, we're going to hop into recursion. All right, and again, this one, if you have trouble with this, don't sweat it. This is a more complicated concept, and we're going to cover it for exposure, but you do not need to know recursion to make it into Code Platoon. Excuse me. The process in which a function calls it. So recursion is the process in which a function calls itself. Using recursion to solve a problem requires two cases, a base case and a recursive case. The condition in which the function stops calling itself, the case in which the function returns itself. So Moya asked, well, we need to know it eventually. You need to know that recursion exists. Depending on the language that you're in and the problems that you're working with, you may run into recursion more frequently, but you don't, like, and just like everything else, like at the end of this class, at the end of Code Platoon, at the end of the first year of being a developer, at the end of the 10th year of being a developer, you're never going to memorize everything, right? And you will learn recursion here. You'll touch on it in Code Platoon. I have not written a single recursive function since I've become a full-time software developer in my day job. I had to do it during my apprenticeship. I had to write, I had to implement Minimax, which is a game, like a game algorithm. So I basically had to code a unbeatable version of tic-tac-toe from scratch. And so like that was really the only time I've used recursion outside of Code Platoon. But if you end up doing data science, or if you end up working in a functional language, then recursion becomes much more commonplace than it does when you're writing object-oriented JavaScript and Python code. But Leo may have something to say on this, but usually like recursion, they'll talk about that when you get like your bachelor's in CS, and because this is kind of like an academic problem, and most of the time when you can solve something with recursion, you can probably solve it quicker as a functional solution. And we'll kind of dive into that tonight, and I'll show you why. I mean, recursive, or a recursive solution can be novel, and there are certain problem sets where it's mandatory, but most of the time, especially if it's a extensive time to solve, or if there's a lot of operations to solve, recursion will take up much more memory than doing a functional solution within your computer. And you can basically, it's called like blowing your stack, where you recurse too many times and you run your computer, or you run your replit out of memory, and it can't physically do the problem anymore. And that's not something you typically run into with functional programming. And you can definitely do it, especially if you have a lot of nested loops inside of each other. But it's fairly easy to do when you're working with recursion. All right. So two cases when we work in recursion. So there's a base case, which is the condition in which the function stops calling itself. Right. So this is our base case right here. So when num triple equals 1, and then a recursive case, the case in which the function returns itself. Right. And so basically what we have here is, normally, as we've been writing solutions to our challenges, when we hit return, we're usually returning something out of the function, and then that's the last thing we do, right? Like we've solved the challenge. And when you're dealing with recursion, your function is actually calling itself multiple times, right? So when we run the function sum up to with a number in it, say 3, right? We don't just run through the function and then return the answer. We're actually going to call the function with a slightly smaller number, and then we're going to end up calling it again until we hit our base case. And this is called moving up and down your call stack. right? So we call a function, and each time we do a recursive call, the other function sits in memory and it waits there for all of the other recursive instances of that function to resolve itself before they all start to basically return the answer that we're looking for. And it happens very quickly. And so basically in microseconds or milliseconds, as we're measuring it on our computer, but we're going to basically be looking at it in a slowed down process, right? And so in recursion, if I call sum up to, and I give it the number 5, we're going to start working through. And so we use recursion in place of a loop or an iteration. Like we could also write this with a for loop, right? So we could say I equals 5, keep going while I is greater than 0, and then do I minus minus, right? And keep adding to a final result, and basically just add 5 and then add 4 and then add 3 and then add 2, then add 1, and then we stop the loop and we return that number, which I believe is 15. Right, but when we do it recursively, right, so we call our function sum up to 5, and then we're going to call the function. We come in here, we check to see if our base case is hit, and 5 is not equal to 1, so we do not return 1. We come down here into the else, and we return 5, but we also return sum up to 5 minus 1. Right, so now we've called the function a second time, and this one is hanging open because this one is now open. We check again, 4 is not equal to 1, so we do not return 1. We go to our else case and we return 4. And we also return sum up to 4 minus 1. Right, and then we end up calling it again here. We go through the same process with the number 3, and then we go through the same process with the number 2. And then we finally do return to plus sum up to 2 minus 1, which means that we run our function with the sum up to 1, right? Now we hit our base case. We actually hit the true condition. So 1 is equal to 1. So now we return 1. And so we come back to this function that is open on our call stack, and we return 2 plus 1. Right, which is 3, and then we come up here and we return 3 plus 3, right, which is 6, and we come up here and we return 6 plus 4, which is 10, and we come up here and we return 10 plus 5, which is 15, right? And then all of the functions have been opened, all of the functions have been closed, right? And so things have been added to the call stack, things have been removed from the call stack. And once there's nothing left on the call stack, we're done running our functions. We'll then console.log our result, which is 15. All right. So that was a lot. Any questions on that so far? And I know it sounds like a mess, and compared to what you've been doing so far, it is a mess. But it is a way to solve problems. All right, and we're going to do this multiple times. But anything that I said that just doesn't make sense, or any questions that are jumping out at you, feel free to throw them out. Nothing? So we can all solve a problem recursively.
I think in my case, I definitely understand it, but I need to sit down and actually do it. And I'm not going to be fast at it the first time I do it.
Okay. So, and again, excuse me, this is, this isn't, like I said, I'm not expecting everyone to be like, oh yeah, recursion, great recursion. Like I can't wait to learn this. I'm super excited. But it is something that, like I said, it's a useful skill to have, and it's a good concept to understand. And it's just, as part of the class, as part of Code Platoon, like there's going to be some recursive problems in there. So let's go ahead and walk through this real quick. So live in a replit. All right. So if I say, so a real life example of why you'd use recursion, there isn't a whole lot in developing web applications unless you are writing a functional language. So yeah, Leo said, like you can do algorithm design, but there's also languages where you cannot loop, right? So they literally do not have like a for loop or a while loop in them as a concept, and they use recursion to basically fit that need. So recursion is another way of iterating or looping through your problem. And so like I like off the top of my head, like some functional languages like Clojure does not have the ability to loop. You have to use like a recurse built-in function, which does the recursion for you, and it simulates a loop, but like you just can't write a for loop in Clojure. Right. So Scala is another Java virtual machine, JVM, functional language, just like Clojure. And I wasn't sure off the top of my head, but yeah, it doesn't sound like they have a loop in Scala either. I've never written Scala, but it does get used at my company quite a bit for a different project. So I've heard people talk about it, but I've never actually used it myself. All right, so let's go ahead and create a function here. So we'll do sum. We'll do num. Doing it wrong. Fat arrow function this time. Right, and so we need two cases. So we need our base case and our recursive case. Right, and so the base case, where excuse me, where we stop counting at, where we no longer want to recurse, is our base case. Right, and so we can say if num is triple equal to 1, right, return 1. There's nothing going on here. We're not calling the function again, anything like that. So for our recursive case, well, what do you do in the replit? I guess reset to 9. Haven't had that one happen before. All right, and so for our recursive case, this is where we will return something, but then we will also do another function call, right? And so just like if we do a while loop, right, so if I say let x equal 10, and I say while x is greater than 0, right? So what's going to happen here when I run this? All right, so saying while x is greater than 10, or x is 10, while x is greater than 0, console.log, I'm looping. What happens when I hit the run button? No. How many times will it say I'm looping? 10 times. So it's going to say looping an infinite amount of times because I am not moving towards 0. All right, so I have to manually stop this. Now, how do I make this loop only 10 times? I have to move towards 0, right? So I have to say x minus minus in this case. Right, now I've got my 10 loops, right? Because each time I went through, I reduced the value of x by 1 until I eventually got to 0 and then I stopped. Recursion is the same way. If I just call the same num over and over again, so if I say console.log num5, or I'm sorry, sum 5, right? And I hit run, right? Maximum call stack size exceeded. I did an infinite loop with my recursion because I never moved closer to my base case. And my base case is 1, right? Num has to be equal to 1. And that's when I stop basically stop recursively calling my function. So to do that, just like I did this in my loop where I need to move my recursive case a step closer to my base case each time, I have to do the same thing here, right? And so now if I do this, right, there's my 15. So let's go ahead and take a look at this in, and also just for this, if I do, we'll call this sum r for recursive, I guess we can call it recursive right? We can do the same thing. Right, so we can say let result equal 0. And then we can say while num is greater than 0, result plus equal num, and then num minus minus, and then return result. Right, so there's our second 15. So we did the exact same thing with recursive calls that we did with a functional while loop, right? We got the same answer. And it's the same thing. If I don't decrement here and I don't decrement here, I'll basically exceed my call stack. I run my computer out of memory. And if I do it here, I will eventually run out of memory. It'll just take a lot longer, but I will just keep basically adding the number 5 over and over again. All right, so maximum call stack. And then if I do this, all right, it's just sitting there thinking over and over again, so nothing's going to happen. All right, so let's uncomment this. Let's add this back in. This, and so let's grab this. Actually, we'll do the functional one first. Right, and so let's go ahead and visualize the execution here, right? So we solved this in 22 steps, and there's an extra step because of my console dot log there. But so we come in, we load our function into memory, come down here, we're going to call the function. And so we've called the function, num is now equal to 5, result is now equal to 0. And we're going to say, while num is greater than 0, let's start looping, right? And so we come into our loop, we say result is basically plus equal num, so 0 plus 5, so result is now 5. We're now going to subtract 1 from num, it's down to 4, right? We keep going, we add it, result is 9, num is 3, and here again, result is 12, num is 2, right? We're still hitting our while condition, right? So result is 14, num is 1, right? We added in there, there's 15. So now num is 0, is not greater than 0. We're done. We come down here, we return our result, and that's it. There's our return value. Right, and so there we console.log 15. So if we take this and we put our recursive case in here, so this solves it in 18 steps, but this is going to look very different over here this time. All right, so excuse me, I've got a hair on my tongue. All right, so same thing. We're going to come in here. We're going to load our initial function, sum recursive, into memory, and we're going to call it with the number 5. Right, and so num is equal to 5. We check against our base case. This is not true, so we do not do this. We come down to our recursive case. All right, and so we're going to return 5 plus another function call of 5 minus 1, so 4. Right, so now num is 4. Right, so we walk through it again. So num is 3, num is 2, num is 1. Right, so now we hit our base case. Right, so the return value is 1. And that feeds up into the previous function. The return value is now 3. The return value is 6. The return value is 10. And finally, the return value is 15. And we're out of our call stack, and we send 15 to the console. And this one is, so each time we do this, right, notice how these are completely separated blocks, right? We are holding a copy of this function in memory, right? So we are taking up more memory when we do recursive call. And so going up to 5, not a big deal. And this is fairly simple recursion. But basically, you will run out of memory doing it this way quicker than you will doing it with a loop. I don't know exactly what number you can go up to. I mean, all of these virtual kind of REPLs and Python tutor don't have a ton of memory allocated to them, so it's not terrible to run it out. But you will see it that you can basically blow your maximum call stack trying to do something recursively, rewrite it as a functional or iterative loop, and basically solve the problem, no problem. All right. So that was kind of that opening one that we had here. That is it for the slides this evening. So any other questions about recursion? All right, let's go ahead and tackle a recursive challenge here. All right, I'll lead the class through the recursive one. And we can do pyramid. Let me grab my little prep code block. Okay, so with this one, I know in the example, they show the rows nice and neat, but what we're actually gonna see it as is something like this. And actually, I don't even think we have to output it. It's basically just for counting purposes. And we're given the formula. And so basically, if the number of blocks for a row n equals 2 times n minus 1. So right, using recursion, write a function that returns the total number of blocks in a pyramid with a given height. A pyramid looks like this. Okay, so we can tell if there's one row, there's basically one block in that row, right? So 2 times 1 is 2, minus 1 is 1. And same thing on row 2. So 2 times 2 is 4, minus 1 is 3. And our third row, so 2 times 3 is 6, minus 1 is 5. We've got 1, 2, 3, 4, 5, right? And so our example says there's 3 rows, there's 9 blocks total. 5 plus 3 plus 1 is 9. And then if we have a fourth row, we know that we're going to get 2 more in that row, 1 on either side. So that's 7. So 4 rows would be 16. Right? And so we can do this. All right. So we are going to get a number as a parameter. Represents the height of our pyramid in rows. And we're going to return a number, which is the total number of blocks in our pyramid. And example will say see below. And for pseudocode, right? And so I can say my base case, which is the important case. So we need to understand when we're going to stop. Right. And so to get, I will oops. And so for my recursive case, all right. Any questions about how I wrote up my pseudocode? So I will need to use recursion to solve the problem. I need two cases. My base case, I will stop when I have accounted for each row. My top row will always have one block in it. So when I hit my top row counting from the bottom up, I can stop and start to return values. My recursive case, I will start counting from the bottom and I will apply the formula for each row. 2 times n minus 1, where n is the row that I am on. And if I'm given 3 rows, I will run my initial call with 3 and then 2 and then 1. So I will also okay, so I will need to make a recursive call and decrement by 1 each time until I hit my base case. All right, so any questions about the pseudocode? All right, so I'll go ahead and get started on the code. So I will need a base case. And that's going to be if height is equal to 1. I know that my top row, the very top of my pyramid, will only ever have 1 block in, right? I can't control for these. Maybe I only have a pyramid with 1 row. Maybe I have one with 2. Maybe I have one with 100 rows, right? And each of those are going to be a different one. But the one thing that's stable is I have to have at least 1 row in it. And that 1 row will always have 1 block in it, right? So that doesn't change regardless of the height of my pyramid. And so I can return 1 here. Right, and so now I need to do some math. So I need to apply my formula. So I can say 2 times height minus 1. But then I also need to add my recursive column here, which is going to be pyramid. We're going to say height. And this is where I decrement minus 1. Right, and so feel pretty good about this one. Right, so there's my 9 and my 16. Right, so same thing here. If I grab this and we come back over here to Python Tutor, and let's go ahead and give it 5. All right, so same thing here. I've got my function. I load it into memory. Come down here. I'm going to call my function with a value of 5 in there. Right, so I call pyramid. Height is now 5. Check out my base case. That is not true. So I go into the else. Right, so I'm then going to call my second call of pyramid with height minus 1. So I'm calling it with 4. Same thing, call it with 3, call it with 2, and then finally call it with 1. And this is where it gets interesting because this is where I hit my base case, right? And so now I can return 1 out of here. All right, so the return value becomes 1. Right, and then on my next row, so I've got the 3 blocks from row 2 plus the 1 from the top row, right? So I'm going to return up 4. And same thing here. So with 3, I'm going to have the 5 blocks in my third row. And I'm also going to add the 4 blocks from rows 2 and 1. So I'm at 9. We'll get 7 and 9 is 16. Right, and then we'll get 9 and 16, which is 25. Right, and we return out of the call stack. We're done. We send it to the console. Right, and so there's our 25. And again, could do the exact same thing with the while loop with that same formula, but this is solving it recursively. Any questions on how I tackled that? Okay. So let's go ahead. It is 6:54, 6:53. Let's go ahead and take a quick 5-6 minute break here. We'll start back up at 7 o'clock. I need to drink a little water and find a cough drop here. And then once we come back at 7, we'll hop back into the standard challenges. And we'll take a look at, let's see, I believe we finished with rivers yesterday. So maybe we'll take a look at camel case, and I can lead the class through camel case. And then we'll see if you guys are up for splitting up into teams again and doing one as a team, or I can just keep leading through the class on each of these. But let's go ahead, take that quick break, and I'll start back up at 7. All right, welcome back from the break. We're going to go ahead and dive into a non-recursive challenge here. So I believe we finished with rivers on excuse me, it's Monday, so last Thursday. So let's go ahead and take a look at camel case. I think I'll also swing back around to detention because I don't believe we've done that one yet, and that's actually a pretty good challenge as well. Let's see here. So same process here. We're going to open it up. We're going to fork it. We're going to grab our prep code block. All right, and let's grab some stuff out of the README here. Oh, they already got that down there for me. Let's grab this. All right. So let's go ahead and take a look at camel case. There are a couple of variable naming conventions in programming. There are camel case and snake case. The JavaScript language subscribes camel case. Camel case is a naming convention for a variable that contains multiple words. The entire first word in the variable's name is lowercase. Every subsequent word's first letter is capitalized. There are no spaces or underlines between the words. They are combined together. In this challenge, you will write a function that takes in a snake case argument and converts the sentence into a camel case convention. All right, so let's go ahead and take a look at our examples down here. All right, so we've got, my name is Kramer, and this is how you would write it if you were doing it in Python. So this is a snake case, and we need to convert it to how it would be written in JavaScript. And this is camel case. And so far, like everything we've done has been in camel case for JavaScript. Right. So the first word, everything's lowercase. And then after that, each word is going to be, it's going to start with an uppercase letter. All right. So let's go ahead and take a look at this. I've got one parameter, which is going to be a string, which will contain a variable name as snake case. Okay, and so return will also be a string, and it will be our same variable name converted to camel case. All right. Snake case, and we're going to change it to camel case. So example, we'll say see below. All right. So let's start pseudocoding this. I know that I'm going to need to basically separate each word based on this underscore. So what is that telling me? What data structure might I need here, and how am I going to get there? Anyone have any thoughts on that? Okay, so I will need a loop, definitely, because I'm going to have to examine and modify each word. Yeah, so also an array. All right, so I will need to convert my string to an array. How do I split a string into an array? Yep, I said it. So dot split. And what do I want to separate on? So on the underscore, right? So I want to split on the underscore. All right. So now that I have my array with my string in it, or with each, so I will have an array with each element will be a string. Right. And so now I need to basically, I've got my array, I've got everything. So at the end of this step, I'll have something that looks like this. Right. So once I have that array, what do I need to, what should my next step be? Right. So I've isolated each word. Right. And so what would be my next step from going to this? Right. So capitalize the first letter. All right. So once I've done that, so I think so to upper, will do the entire word. And that might be something that we look at. So once we isolate just the first letter, I believe it's to uppercase, right? Might also be needed in there. Okay, and so and how do I take an array and move it back into a string? Nope, not that splice. The opposite of split. Yep, join. All right. So let's go ahead and take a look. I think this is a pretty good start on yes. So it will smush all of the words back together into one big string, which is what we need to do for our last step when we return. All right, so our last step will be to glue everything into one string after. So again, we'll split it out, do what we need to do, and then we glue it all back together. All right. Any questions so far in the prep or the challenge? Okay, so let's go ahead and get started on this one then. All right, so we're seeing the false because we set these up to compare up here. But we can see our variables are coming in here. So this is what we want to see. That's good. All right. So let's go ahead and let's take a look at splitting this. All right, and we said we want to do this on the underscore. So I believe I put the underscore inside a string. Right. So we're looking pretty good here now. All right. And so let's go ahead and take this out of the console.log and let's say let array. I'll just call it R, that's array. And so now if I console.log R, right? And if I want to get to an individual value, if I do this, now I'm just looking at the first one in each one. All right, so let's go ahead and write ourselves a for loop. All right, so we've got my name is Kramer, first name, array of names. Does anyone see any potential problems with our output right now? Yep, we're starting with the first element. So we're starting at 0 here, right? And I do not want to upcase the first letter in the first word, right? So that's an easy fix. Let's go ahead and change that 0 to 1. Right now I'm starting at the 1 index position, which is going to be the second element in each array. Excuse me. All right. So now let's go ahead, and this is where it's going to get a little bit tricky. And I'm not sure how to solve, like, I'm going to do some guesswork here, and we're going to see if we can get through this, right? So if I just want the first letter of each word, right? What's a built-in that I can use to get to that? All right, I'm thinking dot slice. Right, so if I do dot slice, and let's go ahead. So we got the start number, which is inclusive, and then the end number, which is exclusive, right? If we remember from MDN. So let's go ahead and start and end right away. And let's see what we get here. Right, so name, I from is, K for Kramer, right? So that's looking pretty good. Now I should just be able to do 2 uppercase here. I think it's all one word. Nope. All right, so now I've upcased each of the letters. So now what we're looking at is, let's go ahead and do console.log r, and I can also use slice to get the rest of it, right? Oops, I dot slice. And so how would I get all of the letters besides the first letter, right? So this one, I've just got the first letter. How do I get all of the rest of the letters in each word? Anyone want to take a shot at that? So not right. So if we do length minus 1, that would be, I think that would just give us the last letter. Oh, sorry. So it would be R length minus 1. So I think, because again, if we do 0, right? So if we only give it a start, it'll give us everything from where we start and then keep going. Right, so we get name, right? So we start with the 0. Let's move that out to 1. Right, and so now we're getting everything except for the first letter. Right. We don't want to necessarily do a nested loop here, because when you do a nested loop, you make your function a lot less efficient. So you usually want to try and avoid nested loops wherever possible. All right, so now we could look at doing something, let's see here. So let's just do let result, and we'll say that is equal to an empty string. All right, and so let's go ahead and say result plus, I think this will work, but I am not 100% sure that it'll work. Let's clean this up. And then let's just go ahead and console.log result. So we should be able to do string concatenation by doing this. So we just get false, 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 false. And we're getting empty strings here. How about plus equals? There we go. So name is Kramer. And because we're skipping that first element, instead of giving this an empty string here, we could say that this could be our 0 element in our array. All right, so now we're going to make it equal to my. All right, so that's looking pretty good. And now instead of console.logging it, let's go ahead and return it. All right, and now we don't see it being output anymore, but all of our tests are passing. Right, and there's multiple ways that we could have done this. Like we could have basically, because strings are immutable, so you can't change the letter itself like in the string, but we could replace the entire string. So I think we could also solve this by doing like RI is equal to this, and so then we're doing reassignment in place, and then we wouldn't need the result, and we could take R dot join and do it this way, and I think we'll pass. Yep, so we're still passing there. All right, so if I console.log R, all right, so we'll get the array, right? So there's our array where we've changed that. And then if I do a dot join on an empty string, we get it that way as well. So two different ways to solve this. I mean, either one is perfectly valid. Oops. Go on. All right. Excuse me. So those would be the two ways that I would tackle this, and I'm sure there's more ways to solve it, but this is how I would go about it. I mean, we could take the for loop out and do like a dot map or something like that if we wanted to make it even more concise, but not necessary at this point to solve the problem. All right, so let's go ahead. So any other questions about how I solved this one? Anything that looked confusing? All right, so I use slice twice in here. Okay, well, let's go ahead and let's take a look at detention. All right. All of the students in fifth and sixth grade have detention. You can tell a student is in sixth grade if 6 is the highest number in their student ID. If the highest number in their student ID is less than 6, they are younger, and if it's greater than 6, they are older. The same rule applies for fifth grade. Students write a method that takes a student's ID as a string of unknown length and returns a Boolean true if that student has detention or false if they do not. All right. So basically the highest number in their student ID is the grade that they're in, right? So if the highest number is a 6, they're in the 6th grade. If you're in the 5th or 6th grade, you have detention. This particular student has a 7, so they're in the 7th grade. Even though there is a 6, there could be a 5 in there, anything else along those lines, but it's just the highest number. And so this individual would not have detention. Excuse me. Would you like to split up into groups of 4 and take a stab at this one, or would you like me to lead the class through it? Yeah, we got 2 leads and 1 split. Anyone else want to vote?
Lead.
Okay. So it looks like most of the people want to go through this as a group then. All right, not a problem. So let's go ahead. I've already forked this, so let me grab this. All right. So let's go ahead and take a look at our prep work here. All right. So I'm going to have one parameter, which is actually a string, not a number. Okay. So very similar here. So I have a string with alphanumeric values. I need to isolate each character in the string. I then need to determine if the character is a letter or a number. If the character is a number, I will then need to record that number as the highest. If the character is the first number, encountered, I will need to record that number as the highest number found so far. If the character is the second plus number encountered, I will need to compare it against the current highest value number. If the new number is higher, that becomes the new high value. If the new number is lower, discard the value. Once I have reached the end of my string, I will need to determine the highest number recorded is equal to 5 or 6, and if so, return true. Else return false. All right, so from what I typed here, does anyone have any questions? The hard part about this is I could probably do it with a filter, right? So but the hard part is that we're not just looking for if that number occurs, right? We're looking to make sure that it's the highest number. And so I think, like, if it was just like, hey, if this contains a 5 or a 6, return true, then we could probably, like, it'd be pretty easy to do with the dot filter, right? But we need it to be a 5 or a 6, and also that 5 or 6 needs to be the highest number present. And so I'm not saying that it couldn't be done with a dot filter, but I would definitely have to dig into that to see if it would be worth it. And maybe it's worth it just to see if the like could return just the numbers out of it. And there's a whole bunch of different ways that we could look to compare this, but most likely you could even get away without having to split the string into an array. Like, we may just be able to iterate straight through the string here. So let's go ahead. So we can't necessarily do that either, because these are just two cases. So we could also do this, right? So we could put an 8 in here, right? And same thing, like we could do this. Right, this should be true. This should be false. right? That would also return true. And so we have to take a look at each number that's in there. So because it doesn't say the last, it says the highest number in their student ID. Okay. Excuse me. So let's go ahead and get started here and make sure that we can see what we've got coming in here. So let's go ahead and just console.log ID. All right, there's my IDs. I'm getting undefined because I'm not returning anything yet. All right, and so let's go ahead. Our next step then would be right, and now I should see each of the individual characters here. Right, and so what we could do here is we don't, I mean, if we wanted to be like, I don't even think that like I need to convert these two numbers. Well, I have to check because I believe, let's see here. Let's give this a test here real quick. I don't know if this will do anything. So that's false, right? And then that's also false. So we do get, how about this? False, true. So we want to be careful that we're not comparing strings here, because, and I don't remember the rhyme or reason, but it is like when you're comparing them, like there's like a numerical value to each of the characters in the alphabet. So most likely what we would want to do then is do something like parse int. All right, and then we get not a number. And so we could say, let's go ahead and create our holder here. So let result equal 0. And we could say something like, if ID I, and let's go ahead and wrap this in a parse int. Is not equal to NaN. We then want to look and compare it again to see if it is greater than 0, right? So let's just see if in here, let's just go ahead and console.log. And we can do parse int ID I. All right, and so now what excuse me, what I'm expecting here is that if I take each character in this string and I am going to try and parse it to an integer, and it is either going to parse to an integer, like the string of 1 will parse to the number 1, or the string of G will parse to not a number. And so when I put this bang operator in here, that means that basically I'm looking for the opposite, right? So if this does not equal not a number, please come in here and console.log IDI parse to an integer. So what I should see here is the number 1, 3, and 6 if I'm getting what I hope I'm getting. All right, so 1, not a number. So I don't like that I'm seeing everything here. So this. No, so why am I seeing this over here? So let's go ahead and okay, so it looks like there's a built-in here. So use JavaScript's is NaN function. Checking for equality with NaN is always false. So it's always false, and then I'm making it true. So let's go ahead and take a look at this. So back to MDN, so which is a good place to be. So it looks like I can wrap my excuse me, my character that I'm iterating through in is NaN, right? And that will give me a true or false value based on that. So let's go ahead and do that. So let's get rid of this. And we're going to wrap this whole thing. And we're going to do is NaN. All right, and so let's go ahead and run this again. So now we get 1, 2, 3, 4, 5, 6, 7, 8. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm getting it the right amount of times here. So let's go ahead and flip the polarity on this. So we'll put the bang operator in front of the entire thing. Right, and there's my 1, 3, 6. Right, and so again, this is, I mean, what I just did there, I don't necessarily know all of these answers off the top of my head. So like, this is me going through my actual thought process. And so, right, like I did the wrong thing. Like I was trying to like compare equality against NaN, which will always return false because it's a falsy value. And I just got done teaching that like an hour ago. Right. So I went in, pulled that out, looked up a built-in function is NaN. Right. And basically my logic was saying only do this if it is not a number. Right. So if it is not a number, then parse int ID box I, which is also not a number, right? And so when I put that bang operator in there, now I'm saying only do this if this is false, right? And so when I parse int the character 1, that is not a number. It is a legitimate number. So is NaN returns false. And I am flipping the polarity with that bang operator. So I then return true. So now I am only doing this when I actually have a legitimate number. All right. And so now I can move to my next step. All right. And so I need another if statement here. Right. So I can say if parse int ID I. So Now we know that once we get to here, we're only dealing with actual numbers, right? So I can say is greater than result, then we can make result equal to % IDI. So now this time, when we go through here, right, the first time through, we're going to run into 1. And we're going to make it through our first if statement. Then we're going to make it through our second if statement. And we're going to then basically say that the value of result is equal to 1. And then we'll keep going until we get to 3. 3 is greater than that. And so we'll get to, excuse me, all the way back to 6, where then that's the last character. So we finish, the result will be 6, right? So let's get out of our inside if statement, our outside if statement, and then our for loop, right? And we can say return result triple equal to 5, or result triple equal to 6. And then if we can just do true or false, right? And I think I can even take this out of a ternary, but we'll start here first. All right, so let's go ahead and run this. All right, so we get true, and that is correct, right? So let's go ahead and chop the ternary out of here. All right, and we still get that true value. And let's try this one. Now this one should return false because result should be 7. All right, let's just go ahead and console.log result as well so we can see it. All right, so there's 6 and there's 7, and we get our false. All right, and same thing here. I would expect that I would get 8. So there's our 8. Right, and we should get a 6 out of here, and we should get a 5 out of this one. There's our 6, and there's our 5. And same thing, if we did this and put a 4 in here, this should also be false. You know, and we get our 4 and it's a false. All right, so this one, we had some nested logic in here. We had our for loop, right? So had to do some iteration on this. So wasn't doing it perfect the first time around. Looked up what I was doing wrong, figured out how to attack it, got a step closer, hit the run button, see that I'm getting the opposite of what I want, use that to parse it, and then go from there. All right, any questions on how I solved this one? No one's got anything for me?
No questions, but a lot of admiration on how you process it.
Okay, so let's see here. Could you use .test? I'm not familiar with .test. So like regex.test. So let's see here. The test method executes a search for a match between a regular expression and specified string, returns true or false. So Regex objects are stateful when they have global or sticky flags set. So I don't think so. Well, I mean, we can check here, right? So like we could do this. Where is so we could say 6. And we could throw a 6 in here. Let's go ahead. Okay, so that gives us a true. So if we done that, we still get a true because it's still finding the 6, so it's not seeing it. And you may be able to, so for those of you that have never heard of regex or regular expression before, you will cover this in Code Platoon, and it is useful, but it is beyond the scope of this class. And it is also, in my opinion, a nightmare. There's 2 jokes about regex. One is if you have a problem that requires regex, you have 2 problems. And the plural of regex is regrets. So like, and there will be individuals, and I don't know what's wrong with their brains, but that like regex will click and you will really enjoy it. But for most people, regex is like it's kind of a pain in the butt. And the other thing too is like so there are regex libraries out there that have like a lot of like pre-built useful stuff in it, and the whole purpose of regex is for pattern matching. And where it's useful is right, so like when you are typing in, so like if I go to oh, I don't know, like where like just AT&T.com, and I want to, I don't know if I can open an account here or not. Maybe this my AT&T, go to my account, have an account, or let me create a new account. Create one now. All right, so notice how I'm getting the red error here. And so if I say, right, so be sure to enter an email with the correct format, right? So if I do Charles at me, comma, com, right, like it is still yelling at me. It is using regex behind the scene to pattern match. Like this is an invalid email address until I give it some letters, at least one letter, an @ symbol, at least one letter, a period, and then probably like 2 letters. I don't know if there's any single letter domains out there or not, right? So still invalid, but now I've got a valid email, right? If I get rid of this and just go straight to the dot, like invalid email, right? If I put a 1 in here, good. If I put a 1 on the other side. So this is using a regular expression, and very common for form validation, right? So I've got this, probably the same thing down here if I may not do anything, but like a zip code, it's only like this is like a locked field, but notice how like this is disabled until I hit one of these, right? And so all of that is being done with regular expressions. So, and I'm just trying to think, so like, right, and so like there's all sorts of websites out there that help you with your regex. Like they have all the different pre-built in ranges, everything like that out here, and you'll play with these in Code Platoon, probably any other boot camp that you go to. But regex for me is not easy and it's not fun, and I'll generally try and solve a problem without it unless I have to. And there's plenty of problems that you have to use regex for, or regex does truly make it easier. So and so like email standard regex, right? So like we can use simple ones, but like this is the full regex pattern to make sure like an email, like catching all of the edge cases to make sure that someone puts in a valid email. And I do not know who wrote this, but I'm sure it took a while to do it. And there's packages that use it and like keep the standards up to date. But if someone said like, hey, Charles, we need you to put regex in a form that people can put their email in, I'm not going to figure this out on my own. I'm going to Google how to regex an email, and then I'm going to find like a trusted regex, right? Like there's all of these internet standards and protocols and everything, and I'm going to copy and paste that regex into my program, and I'm not going to write it by hand, right? Because this is nuts. Right, so like email regex, right? So like this is the current version, compliant one. Perfect URL regex, IP address regex, a phone number regex, right? Like all of these have already been built out. All right, they've got it in different languages. Swift is the Mac OS programming language, Perl, Ruby, all right, Java, Ruby simple version, .NET, C#, like how to do it in SQL. Yep. And so like there's a whole, like the longer you can go without having to involve regex, the better off you are. Right, even there is no perfect email regex, hence the 99.99%. All right. So that is just kind of like a quick download on regex. All right, so it is 7:56. I'm gonna give my voice another quick break here. 7:57. So I'm going to get started back up at 8:02. And I think we should be able to knock out probably like 2 more challenges tonight if I keep leading one more, if you guys want to take a crack at one. But we'll decide that when I get back here from drinking some water. Now I'll be back at, excuse me, 8:02. All right, everyone, welcome back from the break. We're going to take a look at another challenge here. We'll take a look at the 2 strikes one. If you, and again, same question, I'm happy to lead the class through this one as well. But if you do want to take a crack at it in teams, I'm happy to break it up that way as well. We could do the prep work together. But this one is definitely a little bit more on the tricky side, if I remember correctly. So let's go ahead and take a look at this, and we'll get the prep work out of the way at least. go ahead and fork it. Okay, so we are going to write a method that takes in a string array of license plate numbers. The method should return a string array of any plate numbers that appeared at least twice. If none of the plate numbers appeared more than once, the method should return an empty array. All right. Excuse me. So let's go ahead and take a look at the prep work on this. So we're going to get a array of strings. Each element will be a license plate number and may appear one or more times. Return is also going to be an array of strings that will include the all license plate numbers that appeared at least 2 times in the input array. All right, and so examples, see below. All right, so let's go ahead and take a look at pseudocoding this. And so we are going to, we will need a results array that keep track of duplicate plates. So what built-in can we use to add a new element to an array?
Splice?
Not-
No,
but- Yep, dot push. So you can use splice to add an element to an array, but I think that would be overkill unless we were looking to add it in a specific place, or if we were looking to remove something and add something at the same time.
got it. Thank
So
you.
no worries, just to add it. And we could also use, I think, like unshift would just add them in a different order, but this isn't asking for it to appear in any specific order. Okay. Excuse me. Okay. All right, so let's go ahead and start taking a look here. Right, so there's our arrays of plates. Shouldn't matter if it's a string or if it's a number, we don't care. We're just looking for duplicates here. All right, so we need to take this first plate and compare it against the second one, and then the third one, and then the fourth one, and then the fifth one. All right, and then once we're done comparing this one, if it doesn't match to any of these, or even if it does, we don't ever need this plate again, right? So we don't need to then compare this one against this one because it already happened the first time through, right? And so we can take a look at removing it. And so we want to remove it, and we're going to remove the first value. So let's take a look at that. So remove first element from an array of JavaScript. So the dot shift method, remove the first element of the array. Right, and so the shift method returns the shifted element. And so if we do plates.shift, right, there is our first plate in each of our arrays. And then after that, because arrays are mutated, if we take a look at plates, right, notice how it is one shorter, right? So we are physically removing it from the array. So let's go ahead and take a look here, and we'll write our first loop. So we can say for let I equal 0, I less than plates dot length. And we can say, actually, I don't know that I want to remove it, because if I'm going off of plates dot length, I do not want to screw up my count here. So let's see what happens when I do that. If I can make it all the way through here or not. It's free to try, right? So, and then don't need that. And we'll say I plus plus. And let's see what we get. All right, so I get, and here, let me comment you out and comment you out. All right, so because I'm reducing the length of my array each time I go through here and do a dot shift, I'm actually cutting short, and I never actually iterate through the array. So instead of doing that, probably what I'll take a look at doing is assigning plates I. Right, so we'll do let plate to check equals plates I. All right, and now let's go ahead and console.log plates to check. Plates to check was not defined, so I've got plate to check instead of plates. All right, so now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this way I'm counting all the way through my array. All right. And so what we can do here is we will then say let j, so this is our nested loop, equal I plus 1, I believe. And we'll say plate dot length. Oops. And then we'll say j plus plus. All right, and so this way, when I is 0 on the first pass, j is going to be equal to 0 plus 1. So we'll start comparing here. All right, and we'll keep going until j is less than plates dot length. All right, and so now we can see console.log plate to check, and we can also do console.log plates j. And let's go ahead and take a look at this. Whoops, plates j 4, and that's why, because I didn't put them in the right spot. So I should get quite a bit here, right? So here's my first plate, right? And here's checking it against the second plate. There's my first plate again, checking it against the third plate. Here's my first plate, checking it against the fourth plate. Here's my first plate, checking it against the fifth plate, right? And so then here is my second plate, checking it against the third plate, checking it against the fourth plate, checking it against the fifth plate, right? And so do my, yes, and then one more, and then I think I miscounted there, but I think this is doing what I'm asking it to do, right? Let's do this. This will be less confusing. Let's do even better. So we'll do plate to check. Right, so there's plate to check. Right, so there's the first one, and then we're comparing it against the next ones. Right, 1, 2, 3, 4. Right, there's my second plate. There's my third plate. There's my fourth plate, and then my final plate, I'm not really checking it against anything. So I could probably even cut that off to cut down on one iteration. But not a huge deal one way or the other. Okay, so I know that I'm doing what I want to do here. So let's go ahead and let's create a results. And this is going to be an empty array for right now. Okay, so we've got our outside loop and then our inside loop, right, where we've got plates I and plates J. So let's go ahead and say if plate to check is equal to plates J, we're going to do results dot push plate to check. And it doesn't really matter which one we push in there because they're going to be a matching number. And then let's go ahead down here. So we've got my if statement is closed, my inside loop is closed, my outside loop is closed. Well, let's go ahead and return results. Okay, and I get 345 B317, right? No dupe for this one, no dupe for this one, but I get a dupe for this one. All right, so let's do this though. Right, is this what we want? And we get the same thing down here. We get 3 2s instead of just one. So how can we control pushing in too many values into results? Right? Can we, is there, so we can definitely limit the push, right? So we want to limit, so we don't want to push if the value is already there, right? So we need to figure out how, so we could run a set which would basically it's like a built-in mathematical operation that will just pull the unique values out of it. And I think Noel, you're on the right track. So if dot includes, right? So we could probably take a look at a built-in on an array that says like dot includes. And if it includes it, then we don't push, right? So we would only push like unique values in there. So let's go ahead and take a look at that. So array dot includes MDN. Right, and so if we take a look at this, so the includes method determines whether an array includes a certain value among its entries, returning true or false as appropriate. Right, so this array just has the numbers 1, 2, 3 in here. So if we do array dot includes 2, we get a true value, right? And so if we have, if that value is already included in our array, this will return true. We want to trip it to say false. So Noel, you're also correct. We'll need the bang operator in here as well. Right. And so let's go ahead back to here. And so I would do this as just a simple like conditional logic check here. So we're going to do an and. So when we use and, oops. All right, so we can say results dot includes, and we'll just do the same thing, plate to check, right? And so if we run it like this, if plate to check is already in there, this is true. So this will be true and this will be true, right? And so what happens is we end up with the exact same thing, right? Because it's going to say it's already in there, but actually we won't end up with anything because the first time it goes to add a duplicate in there, it won't be in here already. So we should just get empty arrays if I run it this way, right? So there's our empty arrays. Now, basically what we're looking for is if we do this, so now we're saying if we have a match and that match is not already included, put it in there. But the second time, so if we have 3 matching plates, the second time we will have a match again, but this will return true that it is already in there, but we're then reversing it with the bang operator. So this resolves to false each time after the first time we run into a unique duplicate plate. Let's go ahead and run it. All right. And so now we see that we just get this, and it doesn't matter. And actually, I'll grab this whole thing here. Right. And so now we've got tons of duplicates in here, but we should only get 1 for each one. Right. So now, even though there's 1, 2, 3, 4, 5 of them, we're only getting it the one time. And I duplicated this one and we're getting this one. Right. So we know the first time it comes around, we get it. Right. And same thing, I can add a 3 and then a 4 and then a 2 and then a 2 and then a 2 and then a 2. Right. And so now 3 should be duplicate as well. Right. And 2 is, and it doesn't matter how many times we have 2, because of this additional conditional check, we are doing, like, we're basically making sure that we're only pushing it in there that one time. All right. Any questions on how I solved this one? Right. And Leo had mentioned using set, and the set objects lets you store unique values of any type, whether primitive values or object references. So I don't use set a ton, but this is another data structure that basically you can add multiple values into it, but it will only return basically like a unique copy of each value. So a set, we could set up a set as well. I'm not as familiar with it, but you can absolutely solve this problem. There's a couple other problems that you can solve with set as well in these challenges. Let's see. And I'll have to go and teach myself how to do sets so I can teach it to the next class. All right. So that's pretty much it for this one. Any other questions on it? Okay. So it is 8:30. I think we've got time for one last challenge here. Let's see here. Okay, so excuse me. This one might be a good one to tackle and give us a couple of minutes here at the end of the night to discuss anything else. So any objections to me leading through this one?
Not at all.
Okay, so let's go ahead and fork this. Could repeat characters be solved with these sets? I don't know that that would be the way that I go, but again, I'm not super brushed up on set. Set is usually you're returning unique characters, but there's also quite a bit of built-in methods on set, so possibly, but I don't know off the top of my head if that would be the way that I'd go with it. All right. So, and put that in there. And it looks like they give us some help with this one. All right. So let's go ahead and take a look here. So write the function that takes a number that represents the social security number and return the last four digits as a string of the social security number. Look into using the following built-in methods: to string, split, splice, and join. Okay, so let's go ahead and we're going to have an input, which is actually a number. Nine-digit social security number. And we're going to return a string that includes the string value, the last four digits of the input. So example, we'll see below. All right, so I know that I am going to get a number. So the first thing I'm going to need to do is convert my number to a string. Right, and then once I have a string, I know that I can then split it. So convert my string into an array. Isolate the last four digits of the array. And then join the last four digits into a single string. Excuse me. Return my final string value. All right, so this one a little bit less pseudocoding because I know that I'm going to be able to get away with using some built-ins here. So let's go ahead and get started. So let's say council.log Social Security. And we should see 3 numbers over here. All right, excellent. So let's see here. I can never remember. Is it just 2 string? No. Convert number to string in JS. Okay, it is 2 string. Number to string. Don't know why it wasn't giving me some help. All right, so let's see what happens now. All right, so there, notice how these turned white. So I am dealing with a string now. So I believe if I do type of, no, is it going to get mad at me over that? Let's see here. Check type of variable. Yes, I might have to wrap it. No, type of. I think it's because of the order that I'm doing it in. I don't know if this will work. No, that's still mad at me, but it's not a big deal. I know I'm working with it. I think if I assign it out to a different variable, I'll get there. But I know that I'm getting the string over here because again, I'm getting the white text. So let's go ahead and take a look at splitting this. Right, and we're going to do this on an empty string so that I split every single character. Right, and now I know that I need the last 4 elements in here over and over again. Right, so how can I snag the last 4 of these? Right, so I know I've used toString, I've used split. I could use splice. I could probably use slice because I know I don't need to add anything in there. Right, so let's go ahead and say to slice. And let's just take a stab here. We'll start at 4. Right, and so there's that. We could say 5. Right, and there's the last 4 here. Right, I could also say -4, I believe. Right, that gives me the same thing. And again, this helps if you end up with extra characters in the front, but it would hurt if you have them in the back. We're not really being asked to solve for that. So I mean, either start counting at 5 or start counting at -4. It's going to be the same way, or the same end result at this one. And then we can take a look at gluing it all back together now. So we can join. And we'll join on basically every character, no separators. All right, and that looks like our strings. And we can take this out of the console.log. We can return it. And we can say this. Whoops, return Social Security number. We need a space over here. And it looks like we get all true values here, right? So this would be, so again, and this is something all with built-ins. Now we can take a look at reformatting it here a little bit. Right, so when they get a bunch of them chained together, you're more likely to see them like this. And so just only using built-ins, basically doing it in one line, able to parse this information and solve it. Any questions on how I solved this one? You don't have to leave it there, but whatever you put in there, you will get, you basically get as your separator, right? So if I say, just for an example down here, so we'll just do const string equals right, and then we do console.log string.split. Right, so now we have it on every single character. And so let's go ahead and pull this out. And we'll call this let r equal that. And then if we do r dot join, right? So if we just do an empty string here, it's going to put everything back in there. If you don't put anything in here, right, you get commas as the default separator. Anything else that you do put in here, you will get as a separator. Right, and there's no cap on this, right? So I think we could do, I don't know if this will translate. So get to use this one a couple of times a week at work. Let's see if all right, so like whatever you put in there, you get as your separator. All right. Any other questions on this one? All right, so we've got about 15 minutes left. That one went a little quicker than I thought it was going to. Let me see if there's another one that I think I can hammer out here in about 15 minutes. Did we already do this one? It feels like we already did this one. Why does it feel like I've already done this one? But if you don't think
Too
we've
many classes. Yeah, no, I don't recognize it.
okay. Okay, we can solve this one then. All right. So let me go ahead and fork it. All right, so parameters, we're going to get a parameter, which is going to be a string. I'll have a full or a first and last name separated by a space. We need to return the initials. We'll have first, last, we'll have, let's see, we'll just say have names separated by a space, and we will need to account for lack of capitalization as well as names of different lengths, names, etc. All right, so we're going to return a string that represents the initials of each part of the given name, all uppercase. And we'll say C below. All right, so I have a string. I know that I will need to isolate each word in the string, splitting on the space. Store each word as an element in my array of strings. We then need to isolate the isolate each first letter, or isolate the first letter of each word and move that to a results string. Make sure that every letter in my results string is uppercase. All right, so any questions about the pseudocode there? That might be it. Yeah, right, because we had first name, last name, and we had to concat it into a full name. I think that was like the session 2 that we did that. That's why that threw me off. All right, so thanks for that, Chris. My brain can rest easy now because it was definitely scratching my head over that. So let's go ahead and start off by making sure that we can see what we're expecting. All right, so Michael Jordan, Elon Musk, Michael Gary Scott. All right, so that looks good to me. And I know if I do a dot split, and I do not want to do it on an empty string this time, right? Because now I get every single letter, right? And it's great for getting the first initial, but notice how like the J in Jordan is probably like the 8th or 9th index here of an Elon Musk. It would only be like the 4th or 5th index for his first initial of his last name. So it'd make it really hard to get any other initial besides the first one. So if we add in a space, now we're splitting on the space. Right. So now I get Michael Jordan and I get Elon Musk and I get Michael Gary Scott. Right. And notice how our punctuation is still a little screwed up. So we could take care of that right now as well. So we could say to uppercase. Right now, everybody's uppercase across the board. I don't have to worry about it later. All right. So this to me looks good. So let's go ahead and make this our array. Now, let's go ahead and do results, and we'll just make this an empty string for now. And let's go ahead and loop through our array. So for let I equal 0, I less than full name. I'm sorry, it's not full name anymore, just r dot length. And we'll do I plus plus. All right, so let's see what we got now. And you're mad at me, why? Let I length expected a semicolon. Let's just see what happens when I run this. We'll see my error. R I, whoop, come on now. Yeah, reset to mine. There we go. My mystery error went away. Let's go ahead and run. So we get Michael and Jordan, Elon and Musk, Michael, Gary, Scott. And just like in our previous exercise where we were doing camel case, how can I isolate just the first letter? All right, so if I come back here to camel case, what part of this was just the first letter? Right, it was this, right? So it's that slice 0, 1. So let's go ahead, come back over here, and let's take a look at what RI slice 0, 1 is, right? So we're going to start counting at the 0 index position. We'll stop counting at the 1, and it is exclusive. So wherever we stop counting, we do not include it, right? So that looks pretty good to me. We've got MJ, EM, MGS. All right, so this looks pretty good to me. And we've got our result up here, which is just an empty string. So again, same thing. I'm going to take this out of my console.log and I can say result. And we're just going to cumulatively concat here. I have to say that very carefully. Right. And so let's go ahead and console.log our result. So we've got MJ, EM, MGS, and we're still getting false because I'm not returning anything. I'm just returning undefined. So let's pull our result out and let's go ahead and return it. And we get true, true, and true. All right. So it is 8:55. That is this one. We actually hammered out quite a few challenges tonight, right? So we got a recursive one, we did camel case, detention, 2 strikes, last 4, and initials, right? So we haven't done repeated characters yet. Excuse me. So any questions on how I solved this one? But notice how we're starting to see some similarities, right? Like I used some of the same parts pretty much across the board on all of these challenges. So, and then just a reminder, Greg Drobny will be here to kick off session 8 with us on Wednesday. So again, similar to Guillermo, he usually budgets anywhere from 30 to 45 minutes, depending on what questions everyone has. But again, he is the outreach and recruitment manager, so he knows a lot about what it takes to actually make it into Code Platoon from the logistical side, not necessarily the application side, but all the paperwork, all of the financing, all of that stuff. So I am going to stop the recording